All right, example 1 here for 4-10. As a large truck fills its gas tank, the volume of gas in gallons can be modeled with a linear function or a linear equation. V equals 4.8 m plus 8.2, where V is the volume of gas. It's important. And m is the number of minutes it has been filling. Give a physical interpretation for both the 4.8 and the 8.2 parameters in the model above. So that sentence there has a lot of gobbledygook, a lot of big words. All this is asking you to do is explain what the 4.8 and 8.2 mean in the equation. Simple terms, right? Explain what those mean in terms of what this problem is talking about in the context of the problem. Okay, so start by determining which one is your slope, which one is your y-intercept, which one's your m, which one's your b. Well, m, misleading number because it's not the variable m. We know that our slope is typically the piece next to it. So let's cross off m and just put slope there instead. That'll be less confusing. And b is that 8.2. So again, what do those numbers mean though? Saying that the 4.8 is the slope and the 8.2 is the y-intercept isn't enough. It's not explaining what they mean in this specific situation. So again, you have to go back to what's going on in the problem. In this problem, we have a truck that is filling its gas tank. So the gas in the truck is filling up forever how long you're putting gas in it, right? For the number of minutes. So the 8.2, going back to our notes, that y-intercept is your initial or starting value. So that 8.2 must be the number of gallons that were in the truck's tank to start with, right? That starting feed or that starting point. So 8.2 represents the number of gallons. And here, when you're doing this, the more specific, the better. The number of gallons of gas in the tank. And again, keywords to start with. You're talking about that starting or that initial value. Now, moving on to the 4.8. The 4.8 is that slope, so it must be happening each minute, is what my m represents. So 4.8 has to be, 4.8 represents the number of gallons of gas. Again, notice the relationship, the number of gallons of gas being pumped into the tank, and this is going to be the keyword. You can't just leave it at that. You need this next part, each minute or per minute, because 4.8 is not only happening once, right? It's happening however many minutes you're sitting there with the gas tank. So all we did was explain what those meant using what the problem told us and making sense of that. So this next part, the truck's gas tank can only hold 110 gallons of gas. So that is like your maximum. You can't have any more than 110. It's like your max. How many minutes, so they're looking for m, to the nearest tenth will it take to fill the tank? Okay, so I'm going to use that equation. Remember, they gave me that equation above that I'm going to use here to kind of answer this question. So V equals 4.8 m plus 8.2. So they're telling me that it can only hold 110 gallons of gas, and that they're looking for the minutes, which means m is going to be the variable I'm solving for, which means 110 is the V value. So 110 equals 4.8 m plus 8.2. And here you have a two-step equation that I know you guys can solve. All right, 110 minus 8.2 divided by 4.8. So 101, 0.8, yeah, 101.8, and then divide both sides by the 4.8. M is equal to, and notice we're getting a decimal. In all cases, when you get that decimal, you should write down the entire decimal, 208,333, and then afterwards you can go back and round it to what it specified. So how many minutes to the nearest tenth will it take to fill the tank? That would be 21.2 minutes to fill the tank. And there we go. So we interpreted the problem or the question, those parameters, and then we answered and did some math based on that.